Okay, let's have a look at this one now. So first we want to simplify that and then make it the power of 9. So I assume when it simplifies it just has a real or an imaginary part. So let's have a look at it. Minus 2 plus 3i over 3 plus 2i times 3 minus 2i over 3 minus 2i, multiplying above and below by the conjugate of the denominator. So on the top I get minus 6 plus 4i plus 9i plus 6 all over 9 plus 4. Well, that's promising because the 6's cancel and you're left with 13i over 13, which of course is just I. So I power 9 is equal to I times I power 8, which is equal to I times I squared power 4. I squared is minus 1. Minus 1 to the power of 4 is 1. So you're just left with I then. So the answer then is just I, it would seem. Okay, that's the first part. Next, we want to get the root here. So in part 2, we're looking for the root of 15 minus 8i. So expanding on the left, we get a squared plus 2abi minus b plus I squared b squared. So minus b squared is equal to 15 minus 8i. So we can see that ab should equal to minus 4 and a squared minus b squared equal to 15. So if I say a equals minus 4 over b and sub that in, I get 16 over b squared minus b squared equals 15. I'll multiply by b squared and I'll get 16 minus b4 equals 15b squared. So I get 15b squared b4 plus 15b squared minus 16 equals 0 if I take everything to the right. So factorizing, I have a b squared, I have a b squared, 16 minus 1. This one doesn't make any sense because that can't ever equal 0. So b equals plus or minus 1. So it's either going to be, and the a, of course, would be minus 4 over plus or minus 1. So that means the a would be minus or plus 4. So it's going to be a, so that's minus 4 plus I, or the other a is 4 minus I. So there are the two roots for that. Okay. And I was expecting them to be opposite in signs only, which is what's happened here. Alright, the last part here. Use De Morgan's theorem to prove this. Okay, so we'll go with cos theta plus I sine theta cubed should equal cos 3 theta plus I sine 3 theta. So that's cos cubed theta plus 3 cos squared theta sine theta I plus 3 cos theta sine squared theta I squared, and then plus I cubed sine cubed theta equals cos 3 theta plus I sine 3 theta, and we're looking for cos 3 theta, so we're just looking at the real parts. So that means cos cubed theta minus 3 cos theta sine squared theta. They're the only real parts. That's equal to cos 3 theta. Don't really want the sine squared there. So that's cos cubed minus 3 cos sine squared is 1 minus cos squared equal to cos 3 theta. So that's cos cubed minus 3 cos plus 3 cos cubed equals cos 3 theta. So we have our result cos 3 theta equals 4 cos cubed theta minus 3 cos theta, which is exactly what we needed to get there. So finally, we just want to simplify minus root 3 minus I power 10. So that's in minus the third quadrant here. So the modulus here would be root 3 plus 1, which is 2. And then tan theta is 1 over root 3. So let's see what the tan is there. That's 30 degrees, but we want to be in the third quadrant, so we need to add 180 to it. So that means theta is 210. So now we have or, which is 2 cos 210 plus I sine 210 power 10. So that will equal, the 10 is going to multiply here and go on to that. 2, 4, 8, 16, 32, 64, 128, 250, 1024. Oh, actually it says to leave it as a power. 2 power 10. Okay, so let's see what cos 2100 is. A half. And then sine 2100 is minus root 3 over 2I. Now, they don't quite want it like this. We have to simplify it a bit. That's 2 power 9, 1 minus root 3I. Now, is that in the right form? 2 power a natural number, 1 minus I times root k, where k is also a natural number. Yeah. I'll just write the I in the front so it matches up more nicely with it. Yeah, okay, that looks okay for that one.